This is video 12 on collisions and car safety for Darton College's Flip Learning. After watching this video on collisions and car safety, you should be able to describe some safety features of cars, including active and passive features, explain how different safety features work using change in momentum equation to give force, and use the equation to evaluate the effectiveness of safety features. In a crash, a car stops very quickly. Both the car and the occupants have kinetic energy and momentum. The quick change in momentum leads to a large force acting on the cars and the occupants. We saw this in the last video when we looked at the force equation. The force equals change in momentum divided by time. So the shorter the time that the collision happens in, the larger the force. Cars have got safety features such as seat belts, which are designed to reduce this force that the occupants will feel. Large forces are involved in crashes can cause injuries to people. Large amounts of kinetic energy also need to be transferred to other forms very quickly. If we want to reduce the force that is in a collision, then again from our equation there, if we increase the time it takes for the collision, then we reduce the force that the person will experience. So it might sound a bit silly trying to make a collision last for a longer period of time, but if you do increase the length of the crash, then you will decrease the force experienced. Cars are designed to have many different safety features. They've got both active safety features and passive safety features. Active safety features are technologies that are involved in trying to prevent an accident. Passive safety features are components in the car that protect people during the crash. Passive features aim to increase the length of time of the crash, and again, the bigger the increase in time, the bigger the decrease in the force. One safety feature that you'll know about is airbags. Airbags deploy rapidly when there's a collision at speeds above 15 miles an hour. They inflate very quickly and absorb some of the kinetic energy from the occupants. They also increase the time it takes to stop someone's head hitting the dashboard, therefore reducing the force acting on it. When you are explaining these safety features, you need to remember this equation all the time and try and relate to the change in momentum, to the force and the time taken. If the safety feature increases the length of time it takes for the collision to happen, then it reduces the size of the force. Another safety feature you might have heard about are crumple zones. They're built into cars and they reduce the force on the passengers during a collision. In a collision, these areas are designed to collapse. This again increases the collision time and spreads the change in momentum over a longer period, so reducing the force. Cars that look bad after an accident actually show that the safety device has worked well, because the momentum and the energy have been dissipated in the crumpling zone of the car and not on the people. Another important safety feature in a car are seat belts, which have been around for a longer time. They're designed from a material which is quite stretchy. When there's an impact, something called a pre-tensioner locks the seat belt and provides some tension. Your body will continue to move forward as the car decelerates, so the belt will then stretch slightly to absorb some of your kinetic energy, and it also increases the time that you are decelerating, and therefore decreases the forces on your body. After an accident, seat belts need to be replaced because they have been stretched. So if an accident was to occur again, they wouldn't work as effectively, so we need to replace them. A safety feature on roads that you might have seen before are these crash barriers. They appear on most major roads. They work by increasing the collision and the stopping time, and therefore decrease the forces involved. They're designed as one long piece, which keeps the car from leaving the road completely or crossing over onto oncoming traffic. They have also got the ability to detach from the posts that are holding them, and they can stretch out. This allows them to increase the time it takes for the car to stop. Because of their ability to stretch out, it also means that hitting them is a lot better than hitting a brick wall. As a brick wall can't stretch out, it will cause your car to come to a stop in a very short space of time, which means that the force of the impact would be massive. We spent a lot of time talking about passive safety features. We're going to talk about active safety features now. These are what car manufacturers put into cars to try and prevent accidents from happening. An example of an active safety feature is paddle controls. These are buttons around the steering wheel that can be used to change gear or operate the radio. They allow drivers not to take their hands off the steering wheel, which increases safety. Another example is electric windows. It's less distracting to operate a switch than to use a manual window winder. Another example is traction control. This helps to prevent the wheels from slipping when too much power is applied in order to try and prevent any accidents from occurring. Anti-lock braking systems, or ABS, are a good example of an active safety feature. ABS brakes help drivers control cars in hazardous situations, such as when braking hard, or in an emergency, or going into a skid. Can also be used in situations where you've got ice on the road. They sense that the wheels are about to lock and reduce the pressure on the brake pads for a fraction of a second so that the wheel can keep moving. They then reapply the pressure. ABS brakes pump on and off like this repeatedly until the vehicle stops. ABS brakes can reduce stopping distances on dry and slippery surfaces. In some cases, such as loose surfaces like gravel, they increase the stopping distance, but can improve the control of the vehicle as well. Okay, so that brings an end to this video on collisions and car safety. In summary, car safety features include airbags, crumple zones and seat belts, which are passive features, as well as traction control, ABS and paddle controls, which are active features. Passive safety features increase the time taken to change the momentum. By using the equation force equals change in momentum divided by time, we can see that this would reduce the force of the impact. The largest increase of time would reduce the force by the most. Okay, don't forget to bring your notes and your purple book to your lesson, please.